just straight across, what is that at? But circumference is pi over d. So the earliest approximations of pi had to do something with measuring around. Poor little fly that was just kind of hobbling.
It was a cricket.
Oh, it was a cricket? There was a little fly.
I think we saw a little bit.
Thank you.
Coffee.
I wasn't feeling good. It's probably stuck in here all night. Eating the food. But anyway, random sets with pi. But what we saw yesterday was that pi, my flexible ruler wherever he is. Pi is how many, if I was to make a ruler with tick marks of radiuses of whatever size circular object I had, it would take 3.1415926 to go halfway. Right? But is it practical for us to make a new ruler for every new circular object? No. So because that's not practical, then we say, okay, there are these, I went too far. There are these standard measurements that we use. Yes, in America it's different than the rest of the world, whatever, we're like that, sadly. But inches and, well, we do have rulers with centimeters and millimeters and all those sorts of things. We do have these measurements that can measure length. And so in order to get that radian measure, we can just say, okay, well, whatever units you are using, just find the ratio of that with how long the radius is in those same units, and then we'll know how many radians, how many radiuses it would take. I think there's some question in homework, and I think it's towards the end of homework, maybe the very last one, that asks the following question. Ready? Which is greater, 1 degree or 1 radian? What would be your answer?
1 radian.
Why?
1 degree is just
1 tick mark on the protractor, right? But 1 radian is a whole radius measured around, right? Look at the circle that's up there on the left. 1 radian falls around 60-ish degrees. Yeah? Today we'll talk about conversions between degrees and radians, so we'll have it much more precisely than that. But right now it looks to be 60-ish. Way bigger than 1. Because it's 1 radius measured around. Okay, so then yesterday we were talking about how all these angles are just fractions. And so if I was to, before we get into the whole coterminal thing, just to get an idea of angles, because it's going to be helpful. If I was to give you something like, I don't even know, let's do one that's not unit circle, so that we're all in like an even playing field. What if I was to give you something like 13 pi over 12? What quadrant would he be in? Not quadrant 1.
3.
Because that's only half pi
Just kidding.
to 0. 3? How far into 3?
Not very far.
A little bit. How much of a little bit? A 12th. A 12th of what? Oh, a 12th of the calzone. So if you had your calzone and you cut it into 12 pieces, that'd need to be in thirds and then in halves again. Because that'd be 6 and then that'd be 6. Sliced it into 12s. It's all 12 of that whole and one more. 13 12ths, right? Does that make sense? If I cut it into 12ths, that's 1 whole calzone, a little bit more. Okay. Or if I was to give you something like 17 pi over 9. What quadrant is that one?
4.
4. How'd you know, Dylan?
Because it's not 18.
And what's 18?
It would be 2 pi.
So he's thinking of, okay, fine, that's 1 and, well, you probably thought of it different ways. But 9 out of 9 would be over here, right, guys? 9 ninths would be 1 whole. So then what would be 2 whole pies, or 2 whole calzones? 18 ninths. So it's 1 shy. If I was to actually do my fractions, it's 1 shy. So yeah, if you're in the 4th quadrant, just a little bit away from all 18 pieces, 2 pies. So if I was to give you something like 7 pi over 11. Now what quadrant? Quadrant 2. Where in quadrant? I know that's kind of awkward. I'm just meaning, is it higher in quadrant 2 or lower in quadrant 2? Middle-ish? Why? where would this be for 11? I know it's awkward. It's an odd number. I apologize. Kind of. Not really.
4.7. No, 5.5.
5.5, right? Out of 11, and then this would be 11 pi out of 11. So there's a distance of 5.5, and 7 is what? 1.5 away, right?
Mm-hmm.
So this is 5.5, 2.75 would be halfway. Oh, sorry, plus 2.75, 7.75. So then where's 7? Yeah, you're right, it's a little bit higher-ish. Why am I doing really weird angles that aren't in the unit circle at all? To kind of just, whether or not you have that fill in the blank circle from Mr. Che last year memorized, to be like, hey, it's literally just fractions. And as long as you keep straight the idea that, if I can get back to here and zoom in. And zoom in. There, it's your class, everything. She gets tired. You look up. Okay, since we're not zooming in, if you can just keep straight that one, if you want to do the calzone example, sure, I use it, you can just hate it, whatever, it is what it is. It's helped me, and now it's working and isn't letting me select anything. But if you can keep track that 1 pi, that's awkward, pi radians, 3.1415926 radians, radiuses, is halfway around the circle. 2 pi, or 6.28 blah 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 radians, is the full way around. Then just think of, okay, 1 pi could be 6 over 6, or 4 over 4, or 3 over 3, or 12 over 12, or 9 over 9, or 11 over 11, whatever. This can be cut into however many slices, but 1 pi is 1 pi, 2 pi is 2 pi. Just think of where the fraction falls, and it'll help you get into the right quadrant. What am I preparing you for? The unit circle. Is it section 4.1? No. Okay, so let's get off of that and start talking about other stuff that you do need to know for homework. So here we go. Coterminal angles. Come on, my grammarians. Oh, it's up on the top of the board. What does co mean as a prefix? Co? Cohabitate? Cooperate? Yeah, that works. Commingle? Company? That's not a prefix. Okay. To what? What does co mean? Better. I might have heard it, and you guys just all said different words all the same time. It's not to. To be with. With or together. Good. Co usually means with or together. So if co means with or together, wait a minute, co what? Terminal. Wasn't that a part of an angle? Like at the very beginning of section 4.1? What part of an angle is the terminal?
Is it where you go?
It's where you're going. It's the terminal side. Yeah, the terminal side. Terminating. Careful. It's not like a terminal in the airport where you're starting from or ending up, I guess. Anyway, terminating, ending. So, co-terminal. They share a terminal side. Does that make sense? The terminal sides of these angles are together, are meeting, are the same location. But what is not the same is how they got there. Oh. So we actually could use the whole airport example. Like, could you end up at the same terminal but have come from two very different locations? Yes. Except angles always start in the same place. So how could you end in the same place, starting in the same place, but getting there a different way? What if I was to give you something like, ooh, can I go to radians? Let's start in degrees. What if, we'll start in degrees. What if I was to give you something like, I don't know, 27 degrees? It's like 30, but a little bit lower. What's another way of getting to 27 degrees without being 27 degrees? What? Say it one more time.
387 degrees.
When Nathan said 387, why do I know exactly what he's meaning and I'm able to draw it?
Because 360 is a circle.
You're getting there the same, well, you're starting at the same place, you're ending at the same place, but you're getting there a very different way. You're turning a whole 360 from the 27, right? But what's another way of getting there? In homework, it's going to ask you for a positive coterminal angle, which 387 is 1. How'd you get there? By adding 360, but how about negative?
Yeah.
If you're going a negative direction, aren't you doing the negative 360 and just taking away the 27, right? So 360 take away 27 is going to be 343? 33, right? 33. So negative 333. Question. Are those the only ways to land on the exact same terminal angle? You can just spin, right? So you can spin more than once. I mean, you can spin more than once in the positive direction or spin more than once in the negative direction. Okay, now it starts to get a little bit more interesting. But that's in degrees. So in degrees, think of what we did. We took our original theta and we added 360, or we subtracted 360. Yeah, I don't know what happened. Sorry. It was my brain. That's beyond. It was probably my brain. Okay, so you can add 360, you can subtract 360, but guys, we're supposed to be learning radians. So how would it work if we had a radian angle instead? Pause. How do you know it's a radian angle? What would not be present? A degree mark. Now here's the awkward part. Would the word radian be there?
No.
Not always. Well, that's mean. You always put degree marks with degrees. Yeah, but radians are kind of naturally occurring. They figure they don't need a mark. Oh. So it might say radians or it might not. Just be aware. But how would you add 360 in radian units instead? I'm hearing so many weird things. It's just 2 pi, right? 1 full rotation. Is that okay? Which, I mean, depending on the fractions, if this is like 3 pi over 4, then yeah, maybe I'll make it 8 pi over 4. But still, it's ultimately 2 pi or subtracting 2 pi. But as we just talked about, you can spin as many times as you want. Now, wait a minute. Hold on. I'm adding this little n guy. Oh, sorry. I already wrote them without even realizing it. The little n guy is going to stand for multiples of. Now, hold on. If I'm talking about multiples, and if I need to land at the exact same spot, can they be fractional? They can. Can it be a fractional multiple of 360 or a fractional multiple of 2 pi and still land at the exact same spot? Give me an example of a fraction. Not 1 whole, but 3/4. Could you have added 3/4 of a full rotation and still landed at the exact same spot? You could. I thought 3/4 would have been like here-ish. Right? Don't I need a full revolution? If you go up 27, Nathan, how did you get your 387? You added a full rotation 360, right? Could I add some portion of that and still have landed? Does that make sense? So when I'm saying multiples, I mean whole number multiples. And so if we are saying by a multiple of 1 revolution, remember 1 revolution can either be 360 degrees or 2 pi. But I'm going to put on little n's. So adding 360n or adding 2 pi n. But check it. Where n is, that's fun. Does that kind of remind you of the double R that stands for all real numbers? A little bit, right? That little z, not quite, stands for integers. Whoa, integers. Who are those guys again? Numbers. Which numbers? All numbers? But we just said fractions don't get included. Are we in trouble if we're saying integers? No, because fractions are rational numbers. Integers are positive and negative counting numbers. Yeah, good old-fashioned, the numbers you've seen since forever, right? Countings, I don't even know. Counting, I just want to do an adjective. Counting numbers. Meaning, could I add positive 1 360? Yep. 2 360s? Yep. 3 360s? Yep. 187 360s? Yep. You'll land in the same spot. How about negative 1 360? Negative 2 360s? Negative, yep. I can do either of those, and I'll always land in the exact same spot. So let's see how well you guys are doing with radians. Before that, let's get another example. I want you to do the exact same thing. Find a positive and a negative coterminal angle. But this time time, what was I giving you in this one? I was giving you theta equals 27 degrees. How about in number 2, let me give you theta is equal to, should I be really tiny? How about negative pi over 5? Find me a positive and a negative. Call them by a different Greek letter if you want. You can call it alpha, beta, gamma, delta. Hey, you guys have a lot of them now. Pick one. Just don't call it theta again. And don't call it pi. That's awkward. He's a number. Maybe not sigma because it stands for something else. Does someone have one? Phi. Phi, no, right? Phi, chi, psi. Like those last ones before omicron? Is that what it's saying? Little megas. Who has one? 9 pi over 5, right? Wait, can we do that with mental math? Aren't we adding 2 pi? That's hard, isn't it? Wait a minute. What is 2 pi in fifths? See, you're just making the mental math easier. So if you add 10 fifths, it's 9 pi over 5. If you subtract 10 fifths, you get... Oh, maybe radians aren't that bad. You just gotta think fractions. Are we okay?
Is pi over 5?
Pi over 5 would be an awkward 16? No, that doesn't work. 36. Is that what you said? There you go. So you can do your 36 plus 360 and your, negative 36 plus 360 and negative 36 minus 360. But to be honest, I think my brain would rather do the plus 10 fifths minus 10 fifths. Anyway, long story short, this little thing down at the bottom, the definition, 2 angles are coterminal if the secondary angle's measure is some sort of multiple of 2 pi or multiple of 360 away. So if you can set some crazy huge, like if I was to give you something like, I don't know, 1,294 degrees is coterminal with what? You're like, oh, you gotta be kidding me. Well, just start subtracting 360s and see what's left. Because it's in degrees. Or if I was to give you something nasty like, I don't know, 27 pi over 4. Just start subtracting 2 pi's, but hopefully you're subtracting 8 pi over 4s to make it easier. Until you get back to something that's small enough to be in the first quadrant. Positive or negative. Okay, so that's coterminal angles. Co, with, or together. Terminal, ending in the same place. You can only do that if you add or subtract full revolutions. 360s or 2 pi's. Something else from geometry was, sorry, once again on the ceiling. Let's just do this. There we go. Complementary versus supplementary. Do you guys ever wonder why it's off the screen? It's not because I positioned this badly. It's because I got a new projector because the other one died a few years ago. And the new one has different dimensions than the old one. And without positioning that whole apparatus differently, this is the best we can get. So, some of you are probably like, why didn't you just get it fit on the screen? If you ever want to come play with it though, I would love if you could figure out how to. Someday. Complementary versus supplementary. Not complimentary, although hopefully that's what you are in a non-false way to people around you. But complementary, hopefully that's what you bring to your group. But applied to degrees. Do you guys remember which one's which? In degrees, the easy geometry type. Complementary angles add up to be, wrong one. Add up to be 90. Here we go back in geometry. I'm sure there's some sort of spiffy definition. The sum of 2 angles is 90 degrees. But whatever, they add up to be 90. Add up to, I need you guys to put up. down is illegal. Down doesn't work. Only adding up to, meaning two smaller angles than 90 combining to be the larger angle. That's the only way complements work. Same thing with supplements. Angles adding up to be, yeah. But once again, adding up to, not down to. Hold on, we're in radians. Come on. So instead of 90, we could also think pi over half a calzone, right? Or 180. Calzone. Go to pi. In honors, they have, who was it, Alec or someone? It was like, oh, hey, when you're old, you need supplements. I don't know. So in his mind, he's like, the bigger one needs supplementary. Whatever. I'll just see if they had a way of remembering it. It works, maybe. You might remember it that much. But anyway, adding up to these. So what if I was to give you a couple different examples? I want you to find a complement and supplement of both, and I'm going to do them both in radians just because. Let's do something like, I don't know, how about 2 pi over 5? And then how about 2 pi over 3? Ready, set, go. You guys in your groups. Give me a complement and a supplement of both. Yes, they are in radians. We can fractions. Mine is better. Okay. Groups are not working together very well. Come on, talk it out. Some of you already had the answers. Just make sure your group is tracking. Some of you have no clue, so talk it out.
So for the first one, to get pi, you have to add 3 pi, 5 pi over 5, which equals pi. And then to get to pi over 2, you have to add half pi over 5, or 0.5 pi to 2. That's 2 pi.
Are you still talking about?
I'm still talking about the A. That was a complement and supplementary of A. And then I haven't done it yet.
I was a little bit mean with the over 5. I apologize.
Yes. 0.5 pi over 5. Because half of 5 is 2.5.
It's you have to subtract it from pi over 2. So it would be 3 pi over 6 minus.
These add up to, you can subtract. So I don't think you can get a
Bring
supplementary.
Mr. Trey back.
Yeah, you can't get a complimentary.
You can get it. Yeah, you can get a complimentary. Can you get a complimentary for B?
Were you talking about me this whole time?
No.
Were you talking about me this whole time? We just changed. Are you talking about B or A?
Wait, I was talking about A the first time.
2 pi over 5. Is that somewhere here-ish? How do I know that?
It's 72 degrees.
No, that's way too big. What am I trying to do? I'm trying to cut it into 1, 2, 3, 4, 5, and ish. Either way, what would halfway be for 2? Wouldn't that be 2.5 cents? For pi? So it's a little bit below. It's in the first quadrant. Does it have a complement? Yes. But why was it rough? Didn't you have to do pi over 2 minus 2 pi over 5? That means you guys get common denominators. So wouldn't that be 5/10 minus 4/10? So what would be your complement? 1/10. You would have to get common denominators. But there was one because he's below halfway. Nathaniel, go ahead. The problem is if you had the degrees, the multiple choice answer would be in radians, so you would have to convert it back. Not wrong, just harder. Does that make sense? Supplement. That one's a lot easier because isn't pi just 5/5? Aha, I like that one. Why is this one, though, going to be none?
Because 2 pi is already
2 pi over 3.
Look at you add a negative.
Well, no, but it's add up to.
Look at me.
Yeah, but you're still adding up.
Ah, no, I'm not. I'm going backwards.
Adding negative.
A good idea. I was very specific saying up to because you need 2 smaller angles to go ahead and combine to be the larger, not working
So
backwards.
it can't be a negative.
Right. But supplement, that one's easy. It's pi over 3. Why? Because you're always going to pi, and pi is either 5/5 or 3/3 or whatever else you want it to be. Just take away 1. Now, Nathaniel's been over here being like, I like degrees better, I'm going to convert, which is good, except he would have to do extra work to come back to the radian answer, but we're actually going to need to do some converting ourselves. So, let's talk about what he has been doing and make sure we understand it. It has to do with dimensional analysis, building bridges to get rid of what we don't want. Vicky, go ahead.
How do you, okay, so that's finding supplementary and complementary, but how would you find a two-terminal angle? The one that's like positive and negative? I can hear you.
We did examples like that a little bit ago. Hold on. Let me freeze the screen. Come here. The rest of you guys. Degrees. What's a degree? I asked you yesterday and you guys were like, temperature? Anyway. What's a degree? It's 1/360th of a rotation around a circle.
You subtract and add from. Oh, yeah, so we're on 360s are 2 pies. So check it. That's from 360, not 180.
We have to get all the way around to end or land at the same spot.
Can you look
Oh,
to the
either
bottom?
plus
That's what that was
360
for. Okay.
or minus 360 or
Not 180.
plus 2 pi or minus. No. Okay. Here. Vanessa, all the way to the bottom? This way? So, what is 1 degree? I guess it's a tick mark on a pro chapter, but a better way of saying it is 1/360th of a revolution around a circle. That's awkward. Yeah, I know. Tell me about it. I'm sure there's a reason why. And in your brains, you know that you think much better in degrees than radians, right? Like, okay, there's a purpose for it. It's just awkward when you try to talk about it mathematically. And there's a random smiley face. I don't know where that came from. Anyway. Somebody. Looks like this year, but. It's 1/360th of a rotation around a circle. It's 1/360th of its circumference. But anyway, dimensional analysis, converting by multiplying by 1 creatively. That's what you always do when you build a bridge. 1 foot to 12 inches, 1,280 feet to 1 mile. 3 feet to 1 yard. Yes, I'm just using feet. It's an easy one. But for us, degrees to radians, well, if we have degrees, some sort of x degrees, don't we need to get rid of the degrees? I need to multiply by the equivalent, pi radians, and you could technically remember they don't write that radian label very often. I know it's awkward. Pi is not a label. Pi is a number. How many radiuses? But we'd have to multiply by, well, pi is equivalent to 180 as far as measurement-wise, so what happens to my little degree marks? Got rid of what I don't want, and I end up with pi times x all over 180. X being whatever degree it is you're trying to convert. But if I'm going the other direction, I have some sort of y. They probably won't tell you radians, but you have to understand it because there is no degree mark. What are you going to multiply by this time? Yeah, so I need to bring in the degrees and get rid of the, now here's where it's awkward. Remember those labels are understood? The understood labels cancel. Maybe the pi's do, but maybe they don't. It depends on whether they both have a pi or not. So just a second ago, we were talking about 1 radian and how it was 60-ish, right? So let's figure out what it was exactly, or what it is exactly. Let's see, 180 y all over pi degrees. So, what is 1 radian? 1 radius measured around. Yeah. In the first quadrant, what kind of high? 60-ish. Yeah. But what is it exactly? Well, 1 radian, they would just say, hey, 1. And you're like, thanks. Is there a degree mark? Nope. So it's an understood. And I'm multiplying it by? Oh, easy. It's 180 degrees. Some of you are going to do that, and it's horribly wrong. 1 radian is not 180. 3.1415926 radians are 180. So what did I do wrong? Is pi a label or a number? It's a number. So if you're doing 1 or 1 literally with radian, you have to realize this is canceling with his little understood radians. That's what cancels. To figure out what 1 radian is, we just have to take 180 and say, oh, hey, what's the ratio with pi? What's 180 divided by 3.1415926? Come on, calculator people, you love it so much on tests. I think it's 57 point something. 50 is bigger than 3. Anybody? The rest of you, you're just totally depending on the cold. Oh, and I got another one. 57.29. 29. Match up. So that's what 1 radian is. About 57 degrees. Yes, way bigger than a degree. What else do we have? Okay. Hold on. Remember how I said that this section is going to have some physics stuff? No. Okay. Physics stuff. If we're talking about physics stuff, arc lengths and linear speeds and angular speeds, areas of sectors, very geometric type formulas. Basically, here's what I need you to realize. With any sort of physics application, with any sort of formulas based on, specifically physics formulas, based on an angle, we need radians. Any sort of physics formula based on an angle. Now, I'm not saying trig of an angle. Not sine, cosine, tangent. Literally the angle itself. Arc length, we've already kind of talked about, just we talked about it in its like ratio form. We've already said that S is arc length, R is radius, theta is angle, but degrees will not work when plugged in because degrees are those little man-made constructs of rotation. We literally need to know proportions of the arc length. Radians are necessary for any physics formula built or based on theta without trig. No sines, no cosines, no tangents to kind of level the playing field. We need the radians. If you try to plug in a degree, you're going to be totally messed up. So it's as easy as you read a problem and saying like, oh, a circle has a radius of 4 inches. Okay, break it down. R equals 4. They're measuring with some sort of standard measurement. They're not calling it, I don't know, 4 inches is 1 R. Nope. Find the length of the arc. Ooh, find S. When the central angle is 240 degrees. Why am I not plugging in 240 degrees? Because it's not in radians. So before you can ever plug into this formula, you have to take that degrees and say, wait a minute, good, who are you? And as you simplify who are you, well, the degrees and the 0 can reduce 24 over 18. Isn't that 4/3 pi? Or 4 pi over 3? If I tried to plug in 240, I would not even be close to the right one. But if I realize what ratio of radiuses that is, aka radians, oh, I'm golden. All I have to do is plug and chug. Arc length is equal to over here? That's it. Over here. What are you going to need to do whenever you see a theta? Get it into radians first. That's it. And think like section 3.5 in chapter 3, like all the scientific, mathematical, well, hey, all the exponentials show up. Am I really going to make you memorize all of these formulas? No. I just want you to realize radians are important. Does that kind of make sense? Kind of, sort of? Okay. So if I were you, I'd take a picture of the formulas. Maybe you want to write them down, not for memorizing for the test, but just to have them close. And homework being like, oh, hey, there's a formula for that. Oh, hey, let me give you one more hint. If you see in homework anything to do with a revolution, not like an uprising, like going around circle one, what would a revolution equal? How many degrees? How many radians? 2 pi. So if you need to convert a revolution, build a bridge, you go to radians or degrees, whatever you want. Sound good? All right, cool kids. With that, you have 30 seconds. Relax, hang out, say hi, check in on your group, turn in a test correction. I don't know. Be productive in some way, shape, or form.